make a start to this anyway. Hello, I'm Caleb, and I'm going to start a basic series for creating a game using primarily JavaScript. We'll be using a little bit of HTML and CSS, but only going to use a basic amount. The goal is to create a basic dungeon game where we'll be able to control a character that can move around, avoid getting killed by a mean monster on the patrol, and make our way through a labyrinth of solid walls. We'll find the key to open a door and make our way to the exit. By the end of this series, we should know how to create a skeleton HTML page, or by the end of this video, with a canvas object. In the canvas object, we'll do all the animation and all game stuff. You'll learn a basic bit of CSS as well as HTML, but the bulk of the work will be done in JavaScript. We'll find out how to update a canvas object and move objects around on the screen in real time. We'll be able to add keybinds in order to control and move our character around. We'll get some collisions going and then program events to happen when those collisions have been detected. And we'll be able to pick up items, have a game over screen and a game complete screen. At that point, you could consider the game to be complete, but it would be kind of boring. So we'll start to add polish to that. There'll be a video on drawing graphics that I'll probably do in Photoshop that will then put into the game, and then I'll replace some, what you'll be working with for the first few weeks, which will be a bunch of boring squares. Those get replaced with those sprites. We'll also start to add a few menu options, such as pause and replay options, buttons. Then, assuming everything's going smoothly, I will look to expand this project into a bit of a larger game. I'll start adding more levels to it. We'll add more sprites and add more different themes and areas in there. Again, to add more, which will let us add more features, including power-ups. We'll add a story with a quest to follow, some NPCs with lines of dialogue. We'll start to smarten up the enemies, make them more of a handful. We can add health bars, create a boss or two, and add multiple behaviours to some of the enemies to make them more interesting to go with. But to start off with, let's start by creating ourselves a skeleton HTML page. I'm going to start off by adding the top line of this, document type HTML. I have no idea actually what that top one does specifically, but I just assume it's there for good measure. We then use opening and closing tags for just about every other type of tag that we put into this HTML document. So we've got the opening HTML and closing HTML document tags here. Into that we're going to insert the head, and we're going to insert the body tags. The difference between the two is the head is what you probably won't see or be aware of going on in the background, while the body will display things on top that you'll recognize. I'm going to hit save. Make sure I save this into the right folder. I'm going to save this as index.html. You're going to see that down in this window here, our first file has been made. Now I'm going to start adding in the links to it. This is going to be first the CSS script. Usually, if you wanted, you could just do style like so and add in all the stuff that I'm about to add in the CSS link in here. But I'm going to keep it all in separate files just for the sake of keeping it kind of clean to look at. This is the type of file we're going to throw in, so it's going to know this is a style sheet that we're passing it. Closing link there. And then over here, I'm going to create my CSS page. In fact, I might just leave that out a sec. Save this and throw this index.html into this window here. So right now we've got a plain boring page that does pretty much nothing. There's nothing put into it yet. I'm going to add in this style sheet, and then over here in the other file I'm going to add in just a few bits on there, and we'll quickly save and refresh just to make sure it works in a sec. The first thing I'm going to change about it is set the color, or the the background color. Let's save this as style.css, and it brings up the formatting for this. Now if I refresh this, where is the... have I not got the background color right? Oh, it's because I put FFF. This is basically in the number system. So the 6 numbers, 2 for red, 2 for green, 2 for blue. And 0 would be complete darkness, black. So if I save this now, refresh, we've got a black screen. If you want though, you can just use 3 numbers to signify that, or you could just type in the word black. I think you have to use... do I have to use quotation marks? No, I don't. So even just typing in the name like this would work. For my own preferences, I like to just type in the numbers like hashtag blah blah blah. I'm going to add in overflow hidden, and what this will do is it will take away any of the scrolling bars whenever this, like if an object on here gets too big, there will be no scrolling going on, which is how I like to keep it. Let's set a margin for 5 pixels, padding set to 0 by default, and those will mostly affect the spacing between different HTML objects that you might put into the window. Back over on the HTML page, I'm going to add in a item called a canvas, and this canvas is basically going to be like the game window. All of the visual stuff that people are going to be able to play and interact with is going to be put into that canvas. If I'm right, most objects that you might have played around with on the internet are probably canvas objects to some extent. They're very interactive at least. Now I'm going to give this canvas an ID called game canvas, and then back in style.css, just so that we can see the game canvas, I'm going to give it a border 4 pixels dash white. I'm going back on my own word, aren't I? White, there we go. The numbers, by the way, go from 0 to 9, then they go from A to F. F is the highest value. So there we go, we got, let's make that 2 pixels, it's kind of thick. And on there, you can see now on this screen, we already have this border going around the canvas, so you can make out where this seemingly invisible canvas actually is hiding. Now, start adding in. That's about all the HTML and CSS that I'm really going to be covering for this video, because it's just about already done. Almost everything else that we need to do, we're going to put into a JavaScript file. So opening, closing those. Opening for script. The source is going, the type is a text to JavaScript, and the source is going to be called script.js. I'm also going to add into here, into the body tag, a function called onload, and another one for onResize. Don't forget to put these brackets in there. Now, by themselves, this will just cause errors and that, but basically when you've added onload and onResize events in here, it will check for when the page is loaded up, it will trigger a function, and when the window is resized, it will trigger another function. So we're going to go over to our script page. I'm just going to write them in immediately. So we need onload and resize. Function onload, that's function resize. I'm going to save this as script.js. You'll see it down here. And what we're going to start off by doing over here is we're going to add in some variables just to start like playing around with. First of all, I'm going to create a variable, or use the keyword let instead of just variable, and this let is going to be a canvas and then a let context. In the onload thing, I'm going to define the canvas. The reason why we have to do it this way is because if the page has not fully loaded yet, but it's trying to look around on the page for a object, it won't find the object because it doesn't exist yet, it hasn't loaded yet. So I just have to make sure that I do all this defining of this variable inside the onload function. When the page is loaded, then start doing these instructions. This first instruction is going to be document get element by ID and game canvas. And if you remember over here, this is the ID we gave to this canvas here, game canvas. Following that, we're going to define the context here by defining the reference to the canvas itself. So the context is going to be equal to the canvas's context. Get context 2D. Now, when we want to do drawing commands, we have to do it all through the context, and that will appear on the screen when we want to start drawing squares and objects. Should be fun. Yo, sup? Yeah. Boom, I'm finding myself back in my chat again. Coffee tastes good. Now that we've got the canvas and the context set up, I'm going to set canvas width, because I don't like this size by the way. I'm going to set it to 800 and canvas.height to 600. I just hit Control S to save, and I'm going to refresh it. And now this canvas object here, you can now see is set to 800 by 600. I'm going to show you just quickly enough how to start drawing objects, or at least a square, onto the screen in the most simplest manner possible. First of all, there are a load of annoying context messages to be called. The first two that we need to always do is context save, context restore. All of the drawing basically has to happen in between these two commands in order for them to happen. I want to draw a square, so I'm going to think of do I want it to have a stroke? What style? Probably. So let's give it a stroke style of red. Next up, I'm going to give it a line width, and that could be just number 2. I think the stroke style here can just be FFOOO. Oh, 4 O's, and that would be the same thing as typing in red. Next up, after we've given a stroke, which is like the border and the width of the border, we're going to give it a fill style, which I think I'm going to make green. No, let's make it blue. I think these numbers work like this with the hashtag. I might have to remove the hashtag in a minute. We'll find out very quickly. And now we're going to ask the context to begin path, as in to begin drawing, and we're going to ask it to draw a rectangle, and we're going to have to give it 4. We have to give it 4 properties. The first is the X, so how far to the left do we want it to go? And we've got 800 to work with, so let's make it 200 squares in. How far down do we want it to go? Let's make it 50 squares in. That way you can see the difference between the two. What kind of width do we want it to have? So 256, and the height can be 150. After it has drawn the rectangle, we want to say context stroke followed by context fill, and stroke basically draws the line that this stroke style and line width applies here, and of course, which makes obvious to you, I guess. And then context fill style will fill it in with that color that we gave it. Now if we refresh, we've got this square drawing. That's our first piece of graphics drawing to the screen, and it's not really that hard to pull off, I think. I hope. We've got some nice starts going on in making. Now, because this is a bit of a doozy, and I'm going to want to draw a few more squares in a sec, I'm going to take all of this and cut it and paste it in here. And now I'm going to close that up and reference it here, draw. Call the function here, draw. So there we go. You're not going to notice any difference. It just makes the page look a little bit tidier to me right now. Now, these are the simplest steps to getting yourself started with drawing objects on the screen. That you could draw a number of different other objects, circles, come to mind. I'm trying to remember what others. Lines, context to line to, context to move to, and etc. But I'm just going to focus on squares for the purpose of this tutorial for today. Now, resize is a bit of a smarter thing to learn how to do. We want to make sure that if I decide to stretch this screen around and make it bigger and smaller, I don't want this window to get cut off here. I want to make sure that the game window will get bigger and smaller to fit within this window that we've got going on here. So this is what my function resize is going to start achieving for me. First off, in my resize, I'm going to define, and I'm going to pick up the width of the screen. Screen width is going to equal to window.inner width. This is the variable name, and this is a function that exists within the browser to pick up the browser's width. And we're talking about the inner width, not the actual, the size of your actual screen. So and as an extra bit, I'm going to remove my padding. So I set a margin here of 5 and a border of 2. So that equals 7, but it goes the top and the bottom, or the left and the right. So we've got to double it to 14. We've got to do the same thing for screen height. Let screen height equals window inner height minus the padding, the 14. Next up, we need to find out what the scale of this all is. Because I've defined the scale over here, the windows.width and height, I'm going to now change it to make some constants up here. So I'm going to create a constant called game width, which is going to be 800, and a constant game height, that's going to be 600. Constants are basically, they're already defined up here. They can no longer be changed. This is the way they are. This is how they are set. You cannot change them once you've made them up. Nope. They're forever stuck at 800 and 600 or whatever number you want to put up here. They cannot be I cannot accidentally go game height equals 50 over here. It would just throw an error at me and say, no way. Which is good. It means you can't make it makes it harder for you to make some mistakes and accidents happen. I know a lot of people diss on JavaScript for those kinds of reasons. So we're going to take X scale, and we are going to we're going to take the screen width divided by the game width, just to find out how big our screen is versus the game screen, or in the scales of, so it will probably give us a number like 1.2 maybe, with that much spare space there. It's going to say that much. And the same thing on the height scale. Y scale is we're going to create a variable Y scale and make it set this is the number is going to be screen height divided by game height. Then we're going to create one more scale, which is actually going to be called scale itself, and I'm going to make it math.min. It's going to return to me the smallest number that I pass to it, which will be either X scale or Y scale. I want it to be the smaller number of the two, because after all, we might not be properly proportionately stretching this around. So we're going to make scale return to us either the smaller number of these two, and then over here canvas.width is going to equal to game width multiplied by the scale, and canvas.height game height times scale. So that way, even though the game height width is 800 by 600, the stretching will happen proportionately. And over here I'm going to say context.scale to scale and scale. So that way even the pixelated objects on here, even if they were meant to be 32 by 32 sprites in the first place, now it'll be 32 times whatever this scale happens to be, 1.5, 0.5, just, automatically scale them as well and proportionately together. Then we're going to recall this function draw. I'm going to do one other thing as well, just quickly to make sure that I don't make some ugly stuff happen. Context.clear rect 0, 0, canvas.width, canvas.height. It's basically going to just clear the drawing canvas completely, blank out the screen, and then redraw this whole square all over again. So, oh right, I need to actually call the resize. I mean, I could just start stretching it around and that would do it. That's ugly. That's ugly. I've typed something in wrong. Gotta find out what that is a sec. What have I typed in wrong? Let's hit F12. It's not detecting any immediately obvious error. Okay, might have to quickly console.log console.log scale. Let's see what kind of numbers is it giving me. Clearly it's giving me a not available number. What? Window.inner width, window.inner height. Just about always forgetting a capital letter somewhere. Anyway, that's the good part now. That's the part that I wanted to see. So now no matter how you stretch this around, you can see that the square object is now correctly proportionately adjusting itself to fit in with this screen. Just nice. There. To finish off with having a bit of fun with drawing stuff, I'm going to once again take all of these drawing commands and shove them into somewhere else. I'm going to pass it a few arguments, as they call them, variables here. So draw square, it's going to take an X, which we might just give it a default, a few defaults just in case that, you know, you call the function without passing it any commands here. We might just set it to a default of 0, 0 and 32, 32. So rect X, Y, width, height. And we could do more like add in the stroke style, line width and fill style within here, if any. And then so by automatically it's drawing a square at this point here with these things. I'm going to make a nested for loop. And that's I'm going to just basically draw a grid. In order to do that, I will need to just quickly define a few things, of course. So xpos is going to equal 0, ypos is going to equal 0. Normally you can just use that symbol instead of the commas. You might call this bad practice, but it works. That's a lot of what I tried to demonstrate here, is how you could get away with a lot of these sloppy things, and the language is very forgiving onto you for that. Let number of squares, I want to make a grid of, let's try 18. We're going to, and then we're going to do square width is equal to the game width divided by number of squares. Let square height is going to be the same thing, number of squares. Now we just create a for loop. We have to define the variable in here, so let x equals 0, and we have to put this here. We can't get away with commas this time. X will continue to increment until it reaches number of squares, because we only want 18, so it's going to increment 18 times. And how is it going to increment? Plus plus, or basically plus equals 1. It's basically the same thing as writing that. Now we need to do the same thing on the y-axis. Let y equals 0. Y increments until it hits the number of squares, and y can increment at a rate of plus 1 each time. And inside here, we basically are going to take this draw square function and repeat it. But in this case, we need to do x times square width, y times square height. So that's the x and y coordinates being punched in. And then for the height and width, we need the square width. And the fourth argument, we need the square height. Now if I do that, we have a grid here. Is that 18? Let's make this smaller number just so I can count quicker. This is a 5 by 5 grid. Good. This will be an 18 by 18 grid. Good. And again, the resize goes around and adjusts itself just fine and dandy to this screen. That's fine. That's exactly how I want it to go. Now, I'm going to take this resize function and call it in the onload function, just so that I don't have to keep doing the resizing myself just to prove that it works, and that I'm just going to have it automatically resize whenever I have to hit refresh, which is just fine. That's basically the first video that I wanted to make, just to demonstrate how you can just get some simple, easy objects drawn onto the screen, or at least the squares, and you've already got canvas rolling. Next week I plan to start adding animation to this, and for the video to update by itself like 60 frames per second, or we'll even just settle for an easy 24 and we'll start moving an object around. We'll have the DVD bouncing, just boop, 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 boop. If you've watched DVDs back in the 90s, you know this stuff. You'd have watched these 90s computers doing this stuff. Yeah, we're going to do that. And if it goes faster than expected, maybe I'll get into doing the input, showing quickly how to add keyboard inputs to it and start moving characters around. But I expect that to be in 2 weeks' time. But that's my video for today. Let's make a start to my project. It looks ugly, but give it time, and I will see you in